This is a video on titration curves. Some people wanted to ask about it because it's not really explicitly in the A2 syllabus, but it is in the AS syllabus. So let's go through some of these things. This is the AS syllabus, by the way, I'm showing here. Right, describe the Bronsted-Lowry theory. I think you're good with that. Describe strong acids and strong bases as being fully dissociated. We're good with that. Water has a pH of 7, acid solutions below 7. I think we're good with that. Number 6 is interesting. Explain the difference between strong and weak acids, including the reaction with a reactive metal. So that's obvious. A reactive metal and a strong acid and a weak acid. Let's call this strong. Let's call this weak. You're going to get more bubbles in the strong acid because the hydrogen ion concentration is greater than in a weak acid. Okay, I think that makes sense. You're going to get bubbles here, but you're not going to get as many bubbles. All right, but this one, the pH meter, if we put a probe in and measure the pH, obviously you're going to get a pH of 3 for a strong acid and a pH of 5 or whatever for a weak acid. That makes sense. Universal indicator. Universal indicators take the colors of the rainbow, Roy, G, Biv. Okay, and with this as 7, so these are, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, something like that. So we know that. Conductivity, obviously a strong acid is going to have a greater conductivity. Greater conductivity because there's more ions. All right, there's literally more ions around because it's strong. Okay, understand that neutralization occurs between that and that. I think we're good with that. H plus and OH minus. Understand that salts are formed in neutralization. I think we're good with that. Now, this is the bit specifically, titration curves and indicators. Okay, so that's what I'm going to look at now. All right, so let me get rid of this stuff. I don't know how to do this, to be honest with you, because as you can see, Microsoft has changed the whiteboard. I don't know if I'll use this for much longer. I might use another one. One called Jamboards seem to be better than this these days. So I might not use this for much longer. All right, here we go then. So let's have a look at titration curves. Titration curves. Okay, now let's get this nice red color. Now, basically, you've got a burette. Okay, and then you've got a conical flask. All right, and there you go. That's basically it. Now, either way could happen, but just for fun, I'm putting my acid in the burette and my alkali in the conical flask. Okay, and what I'm going to do is I'm going to measure the pH of this stuff, of the alkali. The stuff, I'm going to measure the pH of the stuff, in the conical flask. Okay, so that's generally what we do. All right, now what are the types of acids we can say? Well, before I go on, let's do some ground rules. Let's have a different color here. Okay, now I'm going to pretend my acid ratio, and this matters, acid to base ratio or acid to alkali ratio is 1 to 1. Okay, so I'm going to use in here 25 centimeters cubed of a base. All right, it's dissolved, isn't it? So we call that an alkali. And therefore, I'm going to add the acid. So at neutralization, because it's 1 to 1, I'm going to use 25 centimeters cubed of acid to neutralize. By the way, this assumes something that I should have made clear. Okay, they're the same. Not only are they 1 to 1, they have the same. Oops, look at that. They have the same concentration. Okay, so 25 of the acid will react exactly with 25 of the base. That's not always going to be the case, but let's just do the simple case. And they're going to react 1 to 1. Okay, so let's do some examples then. Right, so what we need is, first of all, strong acids. Okay, and number 2, strong acids. And number 3 is going to be weak acids. And number 4 is going to be weak acid. These are the 4 types of titration curve. Okay, let me get a nice color. Strong acid, strong base. Strong acid, weak base. Weak acid, strong base, weak acid. Oh, where am I now? Weak base, I guess. Weak base. So these are the 4 types of titration curve. Okay, as I've said before, often these videos, I think you're clever enough to get this, so do them at ×2, eh? ×2. ×2. So you can just watch what I'm writing, really. But these are the 4 types of titration curve, aren't they? All right, so let's do them in order. Strong acid, strong base. Okay, well, first of all, what would that be? Let's have a strong acid, HCl, plus strong base, sodium hydroxide. Now, don't forget, I'm measuring what's in the pH of what's in the conical flask. Okay, so let's draw. Oh, I can't draw it. I can't use the ruler yet. It's not there apparently. Look at that. You click on the. Oops, click on the ruler. The ruler's coming soon. All right. So let's put this color. It's a nice color. So let's draw a titration curve, which is a graph. Okay, that's pretty good. Now on this side is pH, and on this side is volume of acid added. And this is going to be centimeters cubed, and this is pH. So let's put some numbers here. Let's call this 0. Let's call this 7, and let's call this 14. Okay, now let's call this 25. I don't know what this is. That's 13 or 12 and a half, isn't it? And this is 37 and a half or whatever. All right, so this is the volume of acid added on the bottom and the pH on the right. Okay, so we're measuring what's in the flask. And if you remember up here, what's in the flask is the alkali. So since it's a strong alkali, the starting pH is going to be around 14. So it's going to start, let me use a nice red pen for this. If I can, yeah. The pH is going to start up here, okay? As I've got strong alkali. All right, don't forget we're measuring what's in the flask. We're adding acid, and we're going to add acid to excess. So once everything's been cleaned out, once all the alkalis reacted, I'm going to continue adding acid. So it's going to end up as a pH of about 1, isn't it? So it's going to end up about here when I've added a lot of acid. Now the other thing I can say is at 25, the pH is going to be neutral. Okay, so the shape of the graph looks something like this. Okay, it's going to go down like that, and then quite dramatically it's going to go through there, and then it's going to look something like that. Now, how can you tell this is strong acid, strong base? Well, first of all, where the pH starts, that's a strong base. Where the pH finishes, that's a strong acid. And it will have this kind of look. It will go relatively straight down like this. Okay, it will go down, the pH will decrease as I keep adding acid, and there. So this is, if I saw this without even seeing any labels, I'd know this is strong acid, strong base. Okay. Now titration curves look a bit freaky because pH is a logarithmic function. So that's why they look like this. Okay. If you did concentration without doing the pH, it would be a straight line, believe it or not. All right. But logs do this weird thing. Now, where do you want to use the indicator? Well, you want the indicator. The indicator must change. All right. With a small addition. Okay, so you want a small addition of acid. Okay, so basically you want 1 drop to change the color. Okay, so what do you want then? You want a large pH change, okay, with a small volume change. Okay, that's what you want. Now, where did we get that? Well, we get it here, don't we, in the vertical bit of the graph. So an indicator that works in this region. So I'm going to call this, I don't know, let's call this 2 to, I don't know, 11. So a pH that works in that region. Okay, sorry, an indicator that works in the region 11 to 2. Most of them work in there, so believe it or not, a strong acid, strong base titration, you can use pretty well most indicators because they work somewhere in there. Okay, now crazy but true, the it's neutral at 7. isn't it, here, as you can see. But indicators don't necessarily change at 7, okay? They just give an indication of roughly the end point. By the way, when they've totally neutralized, we call this the end point. That's the end point of the titration, okay? And in this case, the end point is achieved with 25 centimeters cubed of acid. I hope that makes sense. Anyway, this is strong and strong. Let's have a look at the next one. The next one is strong acid, weak base. Okay, so let's move that up here. All right, strong acid, and weak base. Now let's have a look at this one. Strong acid, what would be a good example of this? I think something like HCl and ammonium hydroxide. Okay, this is strong and this is weak. All right. Okay, so first of all, let's draw our axes. Something like that. Don't forget this is, let me give a nice color. Oh no, I like that color. It only gives 3 colors on this one. It's not very good. Oh, not that one, this one. Okay, so this again is the pH, and this is the volume acid added. They're all going to be the same, by the way, the labels. All right, now let's pick nice red there. So this is going to be 0. It's going to be 7. This is going to be 14. Okay, so where is it going to go now then? Well, strong acid. And don't forget we're measuring the stuff in the conical flask. Okay, and the stuff in the conical flask was our base. So it's going to start up there, but it's a weak base. So it's not going to be 14 anymore. Maybe it's going to be 10. So it's going to start there, which is a lot lower to start with. But as I add strong acid, the strong acid is going to be in excess. So it's going to end up down here still, isn't it, about pH 1. Let's put the other bits and pieces in. This is my 25. This is my 12.5. And this is my 37. Okay, and again, because of the conditions we put on it, we know it's going to neutralize at 25. Why is that? Because it reacts 1 to 1 and they're the same concentration. Now, let's have a look at this. What's this going to look like? Right, now this second half of the graph is going to look like this. Okay, just like the one above. And this shows a strong acid. So we know it's a titration curve. We know it's a strong acid. But this one is a bit different. Now, this is quite clever what happens here. Okay, now this one, it goes down a little bit, but then it kind of levels off. And it goes down. Now, I haven't drawn that nicely, have I? But if you look at this region, it does go down a little bit. Then it flattens out. Let me see if I can do that nicer. It goes down, flattens out, and goes down again, something like that. Now, this region, it flattens. Okay, and what's going on? Why does it flatten? Well, in this region, we have a weak base, and we have the salt of a weak base as well. So believe it or not, this region is a buffer. It's a buffer region. Okay, it acts as a buffer, and this is what's known as an alkali buffer. Okay, now I think this is a bit above the pay grade of AS, so I don't think they're going to ask about this, but that's interesting. So if I saw this graph, I'd know, well, it starts here, so this must be a weak base. Okay, and it ends here, so it must be a strong acid. Okay, so that's what a weak base strong acid graph would look like. And this flattens out quite a bit here because it's a buffer in that region. Okay, now you must remember, and this comes up, well, not quite a lot, but it might too. If if I put my acid in here instead of the base, these graphs would be the other way around. They'd be that way around. Start off with a low pH because there's acid in there, and end up at a high pH. Okay, but the way generally they're done is like this way here, but it might be this way. All right, it doesn't matter. All right, so there you go. So that's strong acid, weak base. Next one, I can't remember the order. Weak acid, strong base. Okay, I think you're probably getting the picture now, though, how these things look. So weak acid, strong. Oh, it doesn't look good, does it? Strong base. I'm just doing this quickly because I don't think you really need much of this. All right, weak acid would be ethanoic acid, say. Strong base would be sodium hydroxide. Okay, what would that look like? Well, down there, down there. This is volume acid added. Here's centimeters cubed. Let me put my 25 there. 12.5, 37.5. Let me put my 7. This is a 0, and this is 14, and this is pH. Now, it's a strong base. So what's that going to look like? Oh, let me put my equivalence point in. This here. Now, I keep calling this different names, don't I? This bit is known as the end point, as I've mentioned above. It's also known as the equivalence point. Okay, it's the neutral when it gets 7. So when everything becomes neutral. Now this is strong base, so it's going to start up here near 14, and it's going to do. Oops, that's awful. Can I get rid of that? Yeah. It's going to do what the first one did, and it's going to drop suddenly. But now we have a weak acid, and it's going to kind of do that. Okay, now that's not very good there. So can I get rid of that? Oh, it gets rid of everything. There, it's going to do that, like the strong base did above, and then it's going to kind of go like that, and it's going to end up at pH, I don't know, 3, okay, and it's going to end up about here, and that means it's going to be a weak acid, okay, and this bit, the reason it starts there is because it's a strong base. Okay, now here we've got a nice falling curve. Here it flattens out again because this is our buffer region. And this buffer region is a weak acid, which is this because it's in excess now, and the salt of a weak acid. So that's why this looks like a buffer here. All right, and the last one is weak. Okay, so let's move this up. Okay, I hope this all makes sense, but this is a weak acid, weak base, weak acid, let's do ethanoic acid, weak base, ammonium hydroxide. Okay, let's draw this nicely. I don't want this videos to be too long. If you have a problem with this, just ask, eh? And I have no problem about teaching it in class. So this is volume acid added again, centimeters cubed. This is pH. Let's do my 25. This is my 12.5. This is my 37. This is 0, 7, and 14. Now, if it's weak, well, it's going to start. Let me kind of get a different color. Will we use green? Yeah, we kind of use green. Let's use blue. All right. So it's going to start about 10. It's going to end about 4, 5. All right. But it will go through this point. So this one, you get a buffer, goes down, and you get that. It's kind of a flattened graph. Now we've got 2 buffer regions here. This is a buffer region. This is known as an alkali buffer. And this is the acid buffer. Okay. Now, something I've just remembered I didn't tell you, which indicators to use. Let's go to the top one. Now, the first one, you can use any indicator really, anything that changes between 11 and 2. This one, now, this is strong acid, weak base. This one, you want an indicator that changes in this region. So let's say between 9 and 3, something like that. Okay, so this area, which the other one worked in, the one above, you can't use an indicator that changes in this area, which is 14 to 9. Okay, it's got to be where this bit here between there and there. So that's 9 and 3, say. This is weak acid, strong base. Now you can use one at the top, any change between about here and here. So you can't use ones that change in this region around 3. So it's anywhere between, I don't know, 4 and 12 or so. Okay, an indicator that works between these two. Now, the most picky one is this one. This one, you can't use the top end, you can't use this area, you can't use the bottom end. So this one must change in this region, which is like 9 to 4 or something. This is the weak acid, weak base. You use indicators with a narrow range. Okay, and there you go. Which ones do you use? Oh, well, methyl orange is used for strong acid, strong bases. Bromothiamyl blue, I think, works in here, but I'll have to look them up. But they're not going to expect you to know indicators. They won't expect you to know indicators and range. What they'll do is they'll give you a list of indicators and they'll give you the range, and you've got to pick from an indicator which one would be good in each situation. Okay, let me finish there and see if there's any comments.